Good afternoon, everyone. Welcome to the session, ArcGIS Runtime SDKs, Building Android Applications. Before getting into the session, I just want to quickly know how many of you built Android apps before. Okay, a few of them. And how many of you built Android apps with Kotlin? Okay, that's good. This is one of them in the room. So, yeah, that's just for information that we want to take back. So let's get started. Here is the agenda for today's session. We'll give an introduction with the SDK, how to get started and things like that. Then we'll give you an high-level overview of the functional, the functional overview of the SDK, so that you understand how we design these classes and how we classify them. And then we are going to talk about some key SDK components. We probably will not have time to go through all of them. So what we planned is we will probably go through some open source apps and then kind of explain some of the key components that the SDK has. And then finally, we'll talk some of the latest features that we have and maybe a slide about what's coming in future. All right. With that, let's get started. So what do we mean by building ArcGIS Android apps? So we already, as an organization, we provide applications to the users, which are like collector or a navigator or a workforce. So these are out-of-the-box apps that are built on top of Runtime SDK. But if you are looking for something beyond these apps, where you want to have a custom workflow that your organization needs, then here is the session that you probably are looking for. So you must have heard in the plenary, the US Census is using a data collection app written on Runtime SDK for iOS. So they kind of had a custom workflow, so they built an app with the iOS SDK. Similarly, if you're looking for an Android app, you probably want to get started here. So how do you get started with the SDK? First of all, you can go to developers.arcgis.com and then sign up, have a developer account. It's absolutely free, and you get some free credits as well with that. And then the most important thing is the IDE that you want to develop, work with to develop the apps. For Android, we use Android Studio. That's the standard IDE that Google recommends for developing Android applications. Then the third step would be to download and install the Runtime SDK. So the way we provide the SDK comes in two flavors. One is via Gradle, which will come as part of your application building process. And the other way is you can go to the website developers.arcgis.com, log into your account, and actually download manually the zip file of the SDK. Out of the two ways of downloading the SDK, obviously the most easiest and more popular way is to kind of include the SDK as part of a dependency in your Android project, because we host our SDK on Bintray, which is like a Maven repository. So all you need to do is go to your app, find the root Gradle file, build.gradle file, and then add the Bintray URL as a Maven URL in the build.gradle file, and in the dependencies section, you just include the Runtime SDK. And then you just build the app, the SDK is downloaded for you. Once you have the SDK, you need to get started and build a simple Maps app, right? So to build an app, Android app, you obviously need to have a layout created. And from the SDK that you downloaded, you can just add and map view component to your layout file. Just like the other text views or other views that you have, you need to include the map view. Once you edit the layout file, you probably would want to go to your main activity, and then on creation of the activity, all you need to do is like load the layout file that you created and then create a map, provide a base map, maybe a center location and the scale at which you want to show the map. And that's it. It would be as simple as that, and then you just build the app and deploy it. And probably you need to give permissions to access internet to your Android app. And to develop that, like there are a couple of languages that you can use. And obviously the most popular one for Android before was Java for a long time, and now there is support for Kotlin as well. And we support both. If you have observed in previous years, we would have put Java on top of Kotlin, but now Kotlin has been the more kind of the formal language, even Google recommends. And most of our in-house apps, they already kind of migrated using Kotlin. And a lot of our internal testing things also we do on Kotlin. So that's why the Kotlin has gone above Java for standard Android development. It should be like the code kind of should be similar, or the classes, everything should be similar, whether you're using Java or Kotlin. Obviously, it's easy to build a simple app, but you want to build something beyond that, right? Like you want to have custom workflows. For that, you need some help on how the SDK is. So we provide a lot of SDK resources to kind of guide you through those, and then kind of make you successful in building those applications. And the key of the resources is the developer side. If you go to developers.arcgis.com/Android, that's where you will find the guide doc. I'll probably in a minute or two, I'll show you where it is. So you can also find the API reference. There will be sample details, how each sample is created, kind of detailed explanation of what it does and things like that. And all our sample code is available for free on GitHub. So you can probably go directly to the GitHub and download them, and then work with any sample that you want to and understand the SDK. We also have an active community on GeoNet for developers. So you can post your questions, anything that you have, and people respond, not just employees from Esri, but other developers who are using the Runtime Android SDK, they also participate in that. So you can post the questions there. We have seen the samples in GitHub, but also we provide a sample viewer app, which is something that you don't need to have even an ID or a GitHub account or to download. All you need to do is go to your Play Store and then search for sample viewer, Android, and ArcGIS. That has an app which comprises with all the samples that we have. So it's a quick way, like if you want to quickly check a certain functionality, you can just install that and then see what all functionality we have. And a lot of some of the demos that we do will be using the sample viewer app. And then we also have dev labs, which lets you kind of do the exercises of step-by-step instructions of how to do a display map or a display scene or a certain workflows that you have. So you can always go to the dev labs and kind of learn the SDK. And we also provide open source apps. Open source apps are, some of the open source apps are like the Maps app or a nearby app. So these are slightly beyond the open samples that we provide. These come with certain workflows, slightly more advanced than the simple samples that we provide. These can be used as templates to some of your apps. So and the source code for it is absolutely free. Like if you say it is in between samples and maybe the apps that the apps team, Esri apps team provides. So these are like intermediate between those two types of apps. But they're pretty useful. They kind of follow best practices, some of the best practices for building apps. So it's worth trying those. And if you have any ideas to build open source apps, or if you want to publish your app as an open source app, like you can always let us know. We can make it happen. And another key thing when you're working with Android is to understand the CPU architectures. Since our SDK, although on the top level it's Android, most of our internal code is C++ and we have native libraries. So we have to support all the different architectures that the Android supports. And for a long time we supported the ARMv7, x86, 32-bit libraries. In 100.5, which was released in April this year, we also added support for 64-bit libraries. One of the reasons is that Google Play Store will not accept if your app doesn't have 64-bit libraries anymore from, I think the deadline is August. We are pretty close now. So you can just take back that information if any of your organizations are using Android apps which are still using 32-bit libraries. Yeah, it's probably time to upgrade to 64-bit libraries, native libraries, and then publish the app again. And another concern people usually have with Android apps is the size of the APK. Mostly people kind of build the app with all the native libraries for all the architectures, but that is probably not the ideal way if you want to publish the app to the Play Store. It's okay for dev environment, but for publishing to the Play Store, you probably want to use an filter to your project and then choose specific architectures. And Play Store actually allows you to publish multiple APKs. And then when people are downloading the APK, depending on the architecture of the device, that particular APK would be downloaded for them. So you can read more about it on the Android website on how to do that. So with that introduction, I'm going to quickly show the developer's website. So this is the website, developers.arcgis.com. Like you can see, we have a guide doc, like where to download the SDK, how to install. If you click on the guide, like we kind of give detailed instructions on how to work with Java or Kotlin. And there are fundamental concepts that are explained here, what map scenes, layers are, and etc. So this guide doc is pretty useful, and we also have the API reference, where if you want to just quickly look for a particular class or something, you can work with that. And we also have sample code. Like as I mentioned, like all samples are categorized, and you can go to any sample. Like you can get a link for the GitHub, and then there's also sample code right there on that page. And then I'll quickly show the IDE, the Android Studio. So this is how all our samples are. So I just downloaded the IDE and then imported the samples. You can see all the samples. All you need to do is download it, import it, and then select one of the samples and just run it on the device or emulator, whichever one you prefer. So that's like a quick overview of the developers.arcgis.com website. So let's move on to the second section, which is the overview of the SDK. So any app that you want to build, the fundamental thing that you want to have is a view, right? So that's one of the important components for you. So the fundamental component that we have is the geo view, which kind of extends the Android view group, and all the map view extends the geo view, and the scene view also extends the geo view. So that's our key view component that we have. We also have other view components in the SDK, like the graphics overlay or some attribution text that you want to show on the map, or like a call out, location display. And we are also writing some toolkit components, like if you want to show a compass on the map or a scale bar on the map. So those are all the view components, some of the view components that the SDK provides. But for the view component, you need to have some data, a model component associated with it. And the model component is the one that comes from the map and the scene. And this is how our map and scene components look like. So it's a standard configuration that we kind of match across the platform. So the map or scene are like kind of interoperable between all the Esri products. So if you are working with a map in Pro or working with a map in ArcGIS Online or a map in Runtime, so we kind of maintain the same web map standard and also for this scene. So the map would include layers and tables. We support a lot of layers that either are coming from the ArcGIS services or any OGC services as well. And we also have 3D layers like scene and point cloud layer. So we support all those as well. And so this slide also shows where the source of this data is. So whether it's coming from a desktop environment, ArcGIS Pro, or a service that's coming from ArcGIS Enterprise or a third-party service. So that's kind of an overview of the map and scene and where they get the data from. And the other fundamental components in the SDK are the tasks. Tasks are like the engine that drives the application. So everything that you do within your app is driven by a task. Whether you want to do a geocoding, we'll have a task for it, or you want to do a routing, you will have a task for it, or if you want to take a map offline, we'll have a task for it. And then like there are numerous number of tasks. And then to support these fundamental components, we have other things like if you want to work with Portal, we have the Portal set of API, and we handle the security as well. So like you'll see all the classes related to security as well. And then we have the geometry API as well as symbols, which are kind of fundamental to rendering the maps and layers. So we have seen the overview of it, but we want to show them through some of our open source apps and samples. So we'll go through some apps, and then we'll talk about each of those components. So with that, Shuming is going to demo the Maps app.
Before we look into the key components of our runtime for Android SDK, let's look at a demo first. This is the demo. I'm going to use open source app that Rama just mentioned that you can grab from our GitHub. This open source app is called Maps app. After it's just launched, it opened a web map, and I can go to my current location, which is the convention center, and you can also switch the base map. There's a list of base map, public base map that you can switch to. I can pick this is the image with label base map. And I can also sign into my organization or my portal. That's sign into my organization. And this Maps app uses OAuth to authenticate users. So when signing into the portal, an OAuth login page prompts me for credential. As I tap into my username and password, okay. After enter my username and password, I sign into my portal. And let me zoom to my current location. You can see that I'm signing as a name user, and a list of web maps that I author in my organization. It's listing here. I can like rendering switch to open up one of the web map. And This Maps app also provide other functionalities. Let's say if you want to grab some taco, maybe later tonight with your friend, you can like search it here, do a place searching. When you type the name here, the Maps app provides you a suggestion, a list of suggestions for the places, and you can randomly pick one, and the Maps app will do geocoding this address and add a marker on the map to show the location. Besides that, the Maps app will show you the direction from your current location to the place you want to go. Here's the route and display it on the map. And you can also get turn-to-turn directions besides the route. And this turn-to-turn direction can be translating into multiple language. And that's this Maps app. That's turn back. Okay, let's turn back to the slides. From the Maps app, we see this is a list of the key components used in this Maps app. Map view, we see the usage of map and map view. We see accessing portal and using the authentication. And we're also using geocoding and place searching with suggestion for places. And I haven't demoed the reverse geocoding, but it is also supporting in this Maps app. And we're also doing the routing, and it adds graphics to the graphics overlay when doing the routing. So let's dive into the individual components for using in this Maps app. Start from the 100 release. We separate content and presentation. The maps defines the content that you want to use to tell stories or answer some questions. It defines how those content are organized. And a map can consist of a base map and multiple operational layers. And it implements loadable pattern, meaning that it loads the metadata of the maps and layers asynchronously. And it also defines a lot of listeners so that you can do some certain actions based on what's happening. Say that when the map is downloading or the status of the map has been changed, or you change your base map, you can listen to these events and put in your logic based on these events. And you can also persist your map as a web map and share with your colleagues to the portal. And for the map view, it controls the rendering of the map content. The map view, as Rama already mentioned, it actually extends geo view and adds some 2D functional methods to the map view. It can control the visible extents by setting the viewpoints. And it also can turn on and off magnifier and red or brown mode. And it also can enable sketch editor, view inset, etc. And it also perform identify for layers. Similar to the map object, the map view object also defines some event listeners so that you can add your business logic based on the status of, say, the drawing status of the map view or the status of individual layer. And you can also listen to when the rotation of the map has changed or the scale of the map is changed. And we also seen that the OAuth authentication was used in the Maps app. Behind the scene, this Maps app actually used two key components of our security API. The first component is Authentication Manager. This class is the to-go class and one-stop location to manage all the security-related configurations and resources. And you can do a few operations, such as setting challenge to handle the authentication challenges. And it also managed the configuration to work with OAuth, and it also managed a list of the untrusting server you want to trust in your app. And it also managed the client certificates to work with the public key infrastructure authentication. And it also managed a list of in-memory credential cache to reuse the credential to provide better user experience in your app. The second key component used in Maps app to deal with security is the default authentication challenge handler. This handler provide a default implementation for the UI and user experience to deal with authentication challenges. And we already seen the OAuth authentication experience. Besides that, this default handler also support for other authentication mechanisms such as HTTP basic digest like IWA, and also token base, and also the PKI. It also supports working with self-signed server certificates. To use the default implementation of the user experience, it's really simple, just one line of code to construct a new default authentication challenge handler and set it on the authentication manager. And this is a few examples of the UI to work with other authentication mechanisms, such as from the left is the token base and IWA. The second one is to work with the self-signed certificate, and the third one and the fourth one from the left, the UI to work with PKI client certificates. And we're also seeing Access Portal as a name user. Our Portal API provide a developer gateway to the Portal information model. It provides a lot of high-level coarse-grained APIs to access, use, create, and share the portal content to your organization or on-premise portal. Here lists a few of key classes for the Portal API. The first one is the Portal class. It represents the ArcGIS Online and on-premise portal in the API. And after you sign in your portal as a name user, you can obtain the information of your current name user through the class portal user. And you also can search content such as the portal items or the a group that you belong to through the portal group. And we're also seeing doing geocoding in the Maps app. To perform geocoding, you need to create a locator task from geocoding service, such as the ArcGIS Online World Geocoding Service, or a local locator data set that you store on your device. When working with the local locator data set, all the operations are performed locally on your device, even when there's no network connection. And this locator task also implement loadable interface. And you can set the parameter to do geocoding. And after you execute the task is executed in an asynchronous way, and then you can obtain back the geocode result, which has contain a list of the location and the turn-by-turn directions and some attributes of the geocoding result. We're also seeing doing routing in the Maps app. The Maps app uses the route task to do the routing. Similar to the locator task, the route task, it has the same pattern. It's also loadable, and you can set route parameters on this route task, which you're constructing from either a service or a route dataset stored on your device. And after solve the route asynchronously, you can get the result back. Now I'm going to pass back to Rama to talk about offline workflow.
Thanks, Shuming. Offline is another key component for building the apps, and a lot of interest has been shown in that area over the years. And with offline applications, there are a couple of patterns that you can work with. One is the services pattern, in which we have like an on-demand pattern as well as pre-planned workflows. In on-demand is mostly like an user control and what they want to take offline, which layers they want to include in the offline map and things like that. It's mostly controlled by the user. In a pre-planned is more like an admin workflows where an admin kind of creates these pre-planned areas in ArcGIS Online, and then these are all packaged in ArcGIS Online, and then the runtime app can download whenever they want. Obviously, on-demand mode is more expensive. It takes more time, and it obviously it will use up more network resources, whereas pre-planned is already a packaged content. All it needs to do is download it. Like if you see the code, it will use the same offline map task. As I said, all these operations are managed by the task, and then it will have methods whether you want to download a pre-planned offline map or generate your own offline map with the offline parameters that you want to pass in. And then once you download them, you can edit them and sync them back. The second of the patterns is, obviously we talked about the services pattern, which is network intensive. There's a desktop pattern as well, where we are completely offline, where you don't have any connection. You can still work with the data, but you need to kind of author the data in a desktop environment. Maybe use a Pro, create a mobile map package there, and then which would include the maps that you want to work, and then sideload that mobile map package onto your device and then take it to the field. Especially if you're working with maps. You can also take content offline with individual layers. For example, if you're still working with ArcMap, there is a tool where you can share your data as a runtime content for specific, and it will create an SQLite database and which can be opened in runtime. So the screenshot that you're seeing is the geoprocessing tool that can be used to author a mobile map package in ArcGIS Pro. So with that, I'll quickly show a couple of samples on how working with offline. Switching back, let's see the services pattern first. If I go to the samples again, as I said, we provide multiple samples. You can see there is a generate offline map override, a generate offline map with local, and a generate offline map. The difference between these samples is that the first this one, the generate offline map, it actually downloads your base map. It downloads the feature services that are present in the map. So it's more expensive operation. Like it is going to take some time. Then we have an offline map where you can override some of the settings. For example, let me open and show the parameters. Like you can see, you can adjust the scale levels of the base map that you want to download, or you want to like extend the extent that you want to download, or like select or include or remove layers that you want to do. So those kind of overrides that you can do at the client level and then take the map offline as well. I'm gonna not run that as well. But the third one here is offline map with local base map. So what it does is in 100.5 we released this feature where you can use referenced base maps. So that means you don't really need to download the base map. Instead, you can pre-package the base map and already load it onto the device. But you just tell the app that your reference base map is already located in a particular location in the device. So when it downloads, it doesn't actually download the base map, it excludes, but it just works with the operational layers, the data that you're looking for. So this is also one of the workflows. So I'll let it run. So if you see the sample, it says like it found a local base map. Do you want to use it? Yes, I want to use it. And this is going to take relatively much lesser time than the other samples. But before that, we'll let that run. And then in the meantime, let's switch to the desktop pattern. And let me show you. So this one is a completely for some reason it's not letting me select it. So this is a mobile map package opened on this particular tablet. So you can see the 3 maps that were authored, they come here. For some reason it is not letting me open that. Might have to restart it. Okay, but the idea is like these are mobile maps, like you can open them, those maps, and work, and the styling, everything looks like the way you authored it in ArcGIS Pro. Runtime would render with the same styling, and you can do the geocoding, reverse geocoding, all those stuff completely offline as well. If I switch back, you can see the services pattern one, it already downloaded. You can see it downloaded data that we requested, and it is using a local base map which we already had on the device. So those are the 2 demos that I wanted to do. Unfortunately, the second demo didn't work quite as expected. So, but let's move on and let's go to the third important component, which is in the SDK, which is working with 3D. Shuming is going to show some of the 3D demos in Android samples.
Thank you, Rama. 3D functionality is one of the key components provided by our runtime for Android SDK. I'm going to show some samples using the sample viewer. The first sample I'm going to show is doing the new functionality we brought into 100.5 is doing some analysis on scene view. Let's go to the line of sight GeoElements. What this sample does is to render the buildings from a scene service, and it will check, use the analysis overview, analysis overlay on a scene view to analysis when a taxi is moving in the New York City. if it can be seen from a certain location on the Empire State Building. And you can see that it's performed pretty well and it's doing the checking the visibility real time. The green line means it is visible right now. And when you see a red line, that means it's obstacle from the Empire State Building. And that's changed the location. You can see when change one of these two locations, the analysis is performed real time. So that's one of the sample of analysis. And the other sample I'm going to show is also from this analysis group. It's a view shared location. This sample also loads the buildings from a scene layer. That's give it a few seconds before all the buildings finish loading. And you see that the view share is computing real time. And there are a couple of parameters you can change to calculate the view share. Say you can change the heading of the view share, and you can also change the pitch. There are a few other parameters, such as the angle and also the distance. And we can turn. The maximum and minimal distance will impact the view share in real time. If your 3D app wants to work with in the environment that there's no network connection, we support using the mobile scene package. You can author your mobile scene package in ArcGIS Pro, which will consolidate all your scene data and the scene layers, and it's associating data into a single scene package. So then when you go to the field without network connection, you can still work with 3D. And we had quite a few samples in each group. So here's the mobile scene package. And the sample viewer also provision the data is needing by a specific sample, as we already download the scene package on the device. So I will skip this step. And you can see this is a scene package for the area that you are interested in. And that's performed quite well. You can see the building and the base map. All the data are consolidated in a single mobile SIM package. Another demo I want to show is another new feature we support in 105, which is the point cloud layer. The point cloud layer is a great way to display the data that you obtain more often from the LiDAR data with extremely dense data. Okay. We need to skip continue. Okay, here's the point cloud data. And it's also from a scene layer package. I already downloaded the data beforehand, so I will skip this step. This is the point cloud data obtained from LiDAR sensors. And you can see there are tons of thousands of points from the sensor, and the color and the size of the point represent the value derived from the LiDAR sensor. So the LiDAR data may be difficult to look at because there are thousands, tons of points. That's one thing you can do is you can bundle with a layer which we call integrating mesh layer. What this layer does is adding drawing between the LiDAR points to provide some textures to make your data looks more realistic. Integrate. So this is the integrated mesh layer. You can see the texture with high quality, and I can show that the data has quite high level of details on the rock. You can keep zooming in, and you can see the detail of the rock. Because this calculate real time, so it may take a little bit to load the texture. With this integrated mesh layer, your data looks more realistic, provide better user experience. And this is I think that's Half Dome in Yosemite National Park. Okay. So that's all the demos I'm showing for the 3D. With that, I'm passing it back to Rama.
Okay. Looks like my emulator is back up and running. So I'll show the offline mobile map package one, which I was showing before. So here is the mobile map package that was authored in ArcGIS Pro. You can see that it is side-loaded on the SD card of this particular device. And I could open it in a runtime application. You can see the maps that were authored in Pro available here. I can open any of the map. And the symbology is preserved from the way it was authored in Pro. You can see the legend or the TOC. You can see the information like how the mains and water lines are kind of symbolized based on the type. It's same as the way it was authored in ArcGIS Pro. And then there are some bookmarks that you can set on the map. You can actually search for an address. It's going to use the local locator that is present in the mobile map package for the address and returns the address. You can also search by the name of the water main or something like that. You can perform identify operations on that mobile map package and know the details. Similarly, you can work with other maps as well from that particular mobile map package. So this, as I mentioned previously, it's a desktop pattern where you can work completely offline without any network availability. So with that, I'll switch to the slides. So we have seen some of the key components of the SDK, and we have seen through the example apps and some samples. We just wanted to highlight some of the latest features which we released in 100.5. In 100.5, we started supporting mobile scene packages, subsurface navigation for 3D, the point cloud layers that Shuming showed. There was a lot of performance improvement that was done in 100.5, and also showed the offline maps with reference-based maps. That demo that also came in 100.5. We had support for KML tours, annotation layers. We also started supporting the next generation tile packages and locators as well. And we also had the new symbology model since 100.5. So there are quite new features that were provided from the SDK in the last 1 year. And what's coming is we're gonna probably pretty soon release a toolkit for Android, which would include some of the UI components. Some of the basic ones like the compass and the scale bar would part of the initial release, and more advanced stuff like the AR is also going to be part of the toolkit. So we are currently working on that. We are also currently working on utility networks, reading, tracing utility networks. So that part of work is also in progress. Some of the other works with offline maps like scheduled updates is also coming, which would be part of the pre-planned workflows where you can kind of make scheduled updates to your pre-planned areas. So yeah, a lot of interesting stuff coming in the next releases of Runtime SDKs. And that, yeah, I'll just have a quick review of what we saw today. We just gave an introduction on how to work with the SDK. We saw the overview of the functional overview of the SDK, and then we went through some of the key SDK components through the example apps and samples. And we also talked about some of the latest features and the features that are coming in future. That's all we have. We'll open it up for question and answers, and but don't forget to share your feedback about the session. Just go to your events app and you can rate, and you can let us know what you want to improve or what kind of content you're looking for in these sessions. We'll work on that. Yeah, with that, we'll take questions if you have any. Yep. All right. Thank you very much for attending the session.
Thank you.
Yeah, thank you.